All right, that's fine. Okay. So what did you want to start with?
No.
All right. So number one, it asks us to write these, rewrite each expression in terms of sines and cosines, and then simplify. So cosine x, do I have to do anything to that? No, because it's already a cosine. Then I'm going to look at my identity sheet and find an identity that turns tangent into something with just sines and or cosines in it. So if you look at Q1, you see that tangent is the same thing as sine over cosine. So I can rewrite that as, or tangent as, sine x over cosine x. Everybody happy there? Okay? All that's left to do now is to simplify. What's going on here? Well, I'm really just like multiplying two fractions together, right? So those can cancel. And what am I left with? Just sine x. And I'm done. What's up? I didn't. Okay. I just want an answer with only sines and cosines in it, is what the directions say. So I just converted everything into sines and cosines and then simplified appropriately, and my answer that I'll be left with will be just something in terms of sine and cosine still. 2 is almost identical. Let's.
Oh wait, never mind.
Why don't we do like 4 or 5 or one of those that are a little bit different? 5? Okay. All right. So first thing I want to do is to rewrite things in terms of sines and cosines. So secant is what? Look at your identity sheet. 1 over cosine. And then I don't have to do anything to cosine. Cosecant is 1 over sine. Okay. Now let's go ahead and simplify this. So let's multiply the things in the numerator and denominator together first. Everybody okay there? When I multiply 1 over cosine times cosine, what do I get? 1, right? Because those guys cancel. When I multiply 1 over sine by sine, what do I get? 1. And 1 over 1 is just 1. That would be the answer for number 2. We did 5. So totally different answer to a totally different problem is why it's something different than what we just saw there.
So when you're looking in sines and cosines, y is y, or y is y.
Well, because I've simplified. It says and simplify.
Okay.
Right? So I might get an answer where everything cancels out like this happened because it's simplified. Okay. Yeah, I mean, it just stinks is all. All right. I need like kind of a lot of space to do this. So I'm going to go like all the way down here and just do this on the side because it just, I want to be clear and it just kind of takes a minute to make sure that it's clear. Okay? I wouldn't have put it on there if it wasn't a possibility. This is 4 that we're looking at right now. And there just wasn't enough space on the sheet to do this one. All right, so first thing, let's write everything in terms of sines and cosines. So secant squared y, I can rewrite as what? Or 1 over cosine squared, right? Matt, you weren't wrong in what you said, but it wasn't in terms of sines and cosines, is why we didn't love that answer. And then cotangent I can write as, but that's not in terms of sines and cosines.
You can write it in CSC over SC.
That's also not in terms of sines and cosines,
Wait, why?
because it doesn't have sine and cosine in it.
Wait, cosine over sine.
How about cosine over sine? Let's use that version, right?
Yeah. So you wouldn't use like R6 because it's a
Right.
okay.
Yeah,
Wouldn't you use Q2 instead?
because the directions say to write it in terms of sines and cosines and then simplify. And that first Q2 that you wrote or read didn't have any sines and cosines in it. Had cosecants and secants in it. Okay? All right. Now this just kind of stinks. So what we need to do is we need to make like a common denominator in the numerator and a common denominator in the denominator. Everybody okay with that? I need to combine the terms in the numerator and combine the terms in the denominator, and then I can divide fractions. That's the order which we have to do things. Okay? So what would the common denominator be in the numerator? So, Kendall, you answered for the denominator. Let's go ahead and do that then. So, to make a common denominator in the denominator, I need to turn this 1 into sine y over sine y, right? So when I do that, I would just write this as sine y minus cosine y all over sine y. Okay? Everybody's okay with how I did that? I made a common denominator of sine y. So the 1 I just rewrote as sine y over sine y. Right? Because that's still 1. So then I wrote it with a common denominator. So I have sine y minus cosine y, those are the numerators, over the common denominator of sine y. Right? You know, like if we added fractions, like 1 plus 1/3, we could write it as like 3 plus 1 over 3, right? Where I think of 1 as 3 over 3, and then I add the numerators and keep the denominators, right? Okay. What would the common denominator be for the numerator? It would be cosine squared y. That's correct. So I need to multiply sine y by cosine squared y over cosine squared y. And I'm just going to make that old division bar from the original division bar in the problem thick, so it's easy to see like what happened here, right? That sometimes can help a little bit in keeping things straight. Everybody's okay here? Okay. Now we just have one fraction divided by another fraction, right? So how do we divide fractions? Multiply by the reciprocal of the denominator, right? So the numerator is going to stay the same. And then the denominator we're going to flip. Right here, yes, this is a multiplication dot. Okay. So how do we multiply fractions? Just straight across, right? The tops multiply the tops, the bottoms multiply the bottoms. So my new numerator would be sine y times cosine squared y times sine y. And then I'd have cosine squared y times sine y minus cosine y. What do you think we can cross out? Just curious.
Well, I think I was wrong, but the step before I just crossed out sine y.
So you wanted to do that? Is that what you're saying? That what I wrote in red there?
No, I think I was just doing it.
Well, but it's important we understand like why it's not okay to do something. So that's why I'm pressing you as to like what exactly you're saying you wanted to do.
Out, like,
In the big one,
Yeah,
where you had
no.
two fractions.
No,
No?
like, so you see how you multiply by sine y and then it's over sine y minus.
You're talking about this step, yes.
Yeah. So I crossed out the sine y in both of the.
So you're saying you did
Yes.
this?
Yes.
Okay. Why is it not okay to do that?
I don't know.
Okay. So that's fair, right? Like it's important we understand why we can't do things because we have done things like that before, right? We do cancel things inside of fractions frequently. Why is it not okay to do in this instance? Because we don't have two things multiplied together. Both those things that you're crossing out are part of an addition or subtraction problem. You can't cross out part of an addition or subtraction problem. You can only cross out things that are part of a multiplication problem. So if there was no plus 1 and there was no minus cosine y, yes, those could cross out. But because they're both part of an addition or subtraction problem, you cannot cross them out. Mm-hmm. All right. And then if I look at the next step, gee golly willikers, I guess I would just like distribute things through, and that's probably really as good as we can do. And I think that's as good as you can do. Rather unsatisfying looking answer there, right? Yeah.
I don't know how you got it.
How you got the double fractions? Yeah. I multiplied by the reciprocal. Yeah. No. You should keep it to study from. Why would I take it from you?
Yeah, like you have to do the test.
No. I haven't done that all year, right?
I don't really remember.
Yeah. The reviews are for you. They're not for me. Okay. What do you guys want to look at next? 7?
Or 6. One of those.
Let's do 7.
It's the same thing that you told me.
So 7, we want answers in or we want to rewrite the expression in terms of cosines only. And then to simplify.
Yes.
This one isn't quite as bad. What does that one say again? I don't have them memorized by name like that. Yeah, that's what I would do. Okay. Everybody good with that? What should we do next? They do not, because they're part of addition subtraction problems. Yeah, let's make a common denominator in the numerator and a common denominator in the denominator. And then we can add those fractions. What would the common denominator be? Cosine. So what would the numerator turn into? Cosine x plus 1 over cosine x. Everybody's okay where the plus 1 came from? Cosine. So I have cosine over cosine plus 1 over cosine. That's the 1, right? I need to write it as with the common denominator of cosine, so 1 is just cosine over cosine. Sure, if you want to think about it that way, you can think about it that way. And then what would the denominator be? Very good. We just made a common denominator. No, I just multiplied the number 1 by cosine over cosine. Yeah. And then what?
Now I'm gonna go. You want to multiply by the reciprocal
Yup, I agree.
of the denominator.
Correct. And what do you notice that's going to happen when we do this multiplication? What's they? Yeah, these ones only though, right? Not the other cosines, because those are part of addition and subtraction problems. And that's as good as we can do. Sure. My favorite color is purple.
What? Are you multiplying the reciprocal?
So, sure. So this part stays the same. And I'm going to multiply the yellow by the reciprocal of the blue.
Oh.
Times the reciprocal of the denominator. That's how you divide fractions. Right? Remember from elementary school, dividing fractions is easy as pie. Flip the right and multiply. No.
Okay. So the next
Sure.
answer for number 7.
Yeah, that would be good enough for 7. Yep.
So for number 6, is it just going to be 1 minus cosine?
Squared. Mm-hmm.
That's all we can do?
Yep.
Alright. Number 10.
Well, if you knew how to do number 6, you definitely know how to do number 10.
Or, okay, like, number 13.
Okay.
You know,
All right. So it says to rewrite each expression in terms of sine only and then simplify. So is there a way for me to rewrite cosines in terms of only sines? No. So we're going to have to do some simplifying before we can do anything with an identity. Everybody okay with that plan? What does it mean when I have something like 1 minus cosine and then the parentheses around it squared like that?
I know, it's 1 minus cosine x and 1 plus. The whole thing is squared.
Yeah. So Kendall's right on is that we should think about it like this.
Oh, are they both? So,
Yep.
oh,
They both have the same sign. Because the squared means you have 2 exactly of them, right? 2 squared doesn't mean 2 times negative 2, right? It just means 2 times 2. They're exactly the same thing.
alright, so 2 is the same plus 2 cosine.
Yep. And then what do you think we should do from there? What do you usually do when you have 2 parentheses written next to each other? Yeah, let's FOIL that out. So what I do the first, I get 1 times 1. The outer, 1 times negative cosine. The inner, negative cosine times 1. And the last, negative cosine times negative cosine, positive cosine squared. And then I still have that plus 2 cosine at the end. Sure. Okay. What do you think we should do next? I absolutely agree. What do we get when that happens? I have a negative 1 cosine, another negative 1 cosine, and a positive 2 cosine.
Wait, can't these negative 1 can't that cosine x minus cosine x?
So negative 1 plus negative 1 plus positive 2 is 0, right?
So wait, 1 minus cosine. Oh. Wait, so wait. So it's cosine squared x.
1 plus cosine squared x.
Yeah, I see that.
Would it make more sense if I wrote this first? If everybody's having such a fit about this, would I just cross those out? Negative cosine minus cosine is negative 2 cosines, right? If you have trouble seeing it, just think about a variable. Like negative y minus y is negative 2y, right? Cosine x is just a variable name, right?
Yeah.
Okay.
That was number 2.
We're not done yet because we wanted to write this all in terms of sines. We finally now have something we can plug in or we can write in terms of sines.
Yeah, that's just going to be sine squared.
Be 1 minus sine squared.
Wait, why?
Well, that's what cosine squared is.
Isn't it 1 minus cosine squared?
Sine squared, or cosine squared is 1 minus sine squared.
Wait, but isn't like our answer right now 1 minus cosine squared?
No, it's 1 plus cosine squared. Because we had 2 negatives that we multiplied together to make that positive. And then when I combine the like terms, 1 plus 1 is 2, so I just have 2 minus sine squared. And that's as far as you can go on that one. So the directions say write this in terms of sine only, and then to simplify. So once I got to a point where all I had was sines and numbers, and there's nothing more to like cross out or combine together or anything else, I'm going to stop. Is that okay? Yeah, it's not bad.
All right. Let's do 15.
Okay. So this is a solving problem. What should I do first? Nope, that's a proof. Well, to solve, we just need to figure out the values for x, right? So we want to get x by itself.
So you're going to multiply by the. Actually, you're going to divide by 2.
Yeah, divide both sides by 2.
So it's cosine of x equals -1/2. Yep. I'm going to take the inverse cosine of both sides.
Yep, that'll get rid of the cosine.
So then it's x equals inverse cosine.
-1/2. And then what do you do to figure out the values for x? You go to your unit circle. What are you looking for on the unit circle?
Where cosine is -1/2.
Where cosine is -1/2. Remember which coordinate is cosine on your unit circle? The x coordinate. So look for places where the x coordinate is -1/2. So I see that at 4 pi over 3 and 2 pi over 3. And because we're asking for our answers on the interval of 0 to 2 pi, we are done. That's it. So on these solving problems, if you haven't gone to unit circle, you're probably not doing it right. So you got to use that unit circle. Okay? Does that feel okay? So it shouldn't be too bad, right?
So like for number, are you literally as
Yeah? You could basically do that one the way it's written, right? Just look for the places where the y coordinate is 1/2. There's not much to do there.
Number 1 and 23 is only one of those problems.
Correct.
Oh.
Yep. 2 like the first 13 and 2 like the next 10 or whatever.
Can you do 9?
Sure. Okay. So again, we want to start by getting the 1 by itself, or I'm sorry, the x by itself. So what should we do first? You don't need to do that. I mean, you could do it that way, but it's easier not. Well, you can't do the inverse of tangent because of the squared. Yeah, let's square root both sides. That'll get rid of the squared. When we square root both sides, what do we have to remember? That's what it was. And what's the square root of 1? 1. Everybody's okay with that? So I'm now going to break this into 2 separate equations because of the plus or minus. I can't deal with that at the same time. So I'm just going to break it into 2 equations. One where tan x equals -1 and one where tan x equals +1. Everybody's okay there? And now, Caitlin, we can take the tan inverse of both sides because now we just have tan x's, right? So you're just a little early on that step. And how do I find tangents then on the unit circle? Y over x. So if y over x is equal to 1 or -1, what can you say about y and x? They basically have to be the same number, but they could have opposite signs, right? So 3 pi over 4 will give us, is that going to give us a +1 or -1? That's correct. Because the x is negative, but the y is positive, and negative over positive, or positive over negative is negative still, right? Okay, what other one gives us a -1? That's also correct. That's negative still. because we have just one of them is negative, right?
5 pi over 4.
And also, which other one?
5 pi.
Pi over 4 and 5 pi over 4 are positive. Because in those situations, both are positive or both are negative. But we're not quite done. Because the answer, or the question is asking us for answers from 0 to 4 pi, not just 0 to 2 pi. So these 4 answers are answers that we need, but there's going to be 4 more of them. So if I add 2 pi to each of these, I will get my next set of 4 answers that I would need to include. So when I add 2 pi, I need to make a common denominator. What would the common denominator be? 4. So 2 pi is the same as 8 pi over 4, right? So basically, I'm just going to add 8 to the numerators. Eight pi over 4. You don't get why I'm adding 8 to the numerator?
I do. Well, I don't think I get 8.
So if I have 2 pi over 1, and I want to make it have a common denominator of 4, I multiply the top and bottom by 4 over 4, giving me 8 pi over 4.
Sorry.
That's okay. Sometimes you just have to write it down. You're like, oh, yeah, yep, that's what it is. I asked that question. You know, it happens.
Sorry.
Forget about it. And we're done now, right? Everybody's happy there? That's not bad. What's next? There's lots of them like this one. Which one is, well, this was the last one in that section of ones like that one.
Oh. Then I'm not.
Okay. 21, sure. So 21 says tan x equals 0. So what do we need to do first here?
What are the directions?
This says solve each trigonometric equation for x on the given interval. And then I have, this problem says colon, negative infinity to positive infinity. All of the numbers.
So like pi over 2.
So first thing I would need to do is take tan inverse of both sides, right? And I'm going to solve this problem from 0 to 2 pi, and I'm going to use those answers to give me to find all the other answers, basically. Okay? So how do we find tangent on the unit circle? Okay, so when will y over x be 0? When, you have to have 0 in the numerator, right? So which coordinate am I looking for to be 0? Y. Tangent is y over x, right? When is a fraction equal to 0? When its numerator is 0 and its denominator is non-zero. So we need a place where y is 0, but x cannot be 0.
2 pi to 0.
0 and pi, right? Those are places where the y coordinate is 0, but the x coordinate is non-zero.
What about then? We keep going up.
So yeah, you could keep going, and then you get to 2 pi, and then 3 pi, and 4 pi, and 5 pi. But we don't want to try to list this because the list is going to go on forever, right? What is the pattern going on with these answers? How frequently are they occurring? Pi, right? So I'll just write it as pi k, where k is just any integer value. It's going to represent any integer value. So like k could be 7, that's an answer. K could be negative 13, that's an answer. K can't be a third because fractions aren't integers. Can't be a decimal because those aren't integers. But any value of integer value of k is going to give you an answer. Does that make sense? Okay. You feel good about those then? The solving ones?
Let's open to 21.
That was it for 21. Yeah, it was a quickie. You want to do another solving one? Okay. So, what do I do first? Well, I just need to take cosine inverse of both sides. So, I'll go to my unit circle, and what are the solutions to this from 0 to 2 pi? So, go to your unit circle and tell me the angles from 0 to 2 pi that give us cosine of or equal to square root 3 over 2. Pi over 6 is one of them. Good. Now, if I look at my unit circle, when Caitlin looked at it, one answer was here and one answer was there, right? Are these the same distance apart, whether you're going forward or backwards? Basically, is this distance the same as that distance?
No.
Definitely not. So can I write this with one answer? No. I have to write it with two separate ones. So that's easy enough. I'll just do pi over 6 plus 2 pi k, and then 11 pi over 6 plus 2 pi k, again, where k is just some integer. So basically everything coterminal to pi over 6 and everything coterminal to 11 pi over 6. That's my answer. That's it. It should make sense by the time we get to the end, right? Because you've seen these topics a couple of times, and now like when we simplify things to try to make the answer clearer, like the really complicated explanations distill down into something simple because we know a little bit more about what we're doing, right?
So you add 2 pi. Those are not the same distance.
Yeah, since they're not the same distance apart like that, as opposed to this problem, where I had one answer here and one answer there. So whether I go this way or I go that way, it's the same distance either way. So those we could list with just one answer. Here we have to use two separate answers. Lexi? Sure. Okay, what's next? I mean, there's lots of solving ones on here. Shouldn't we do some identities, though? We only have like 20 minutes left or something, so I don't want to make sure we do some of everything here. If you look at the identities, which ones are you interested in doing? That is in the eye of the beholder. They're all kind of the same to me.
The longest one.
I don't even know that I could tell you that from looking at it.
Maybe 26.
26, sure. There is a lot of letters there, but look at how nice that right-hand side is. Definitely want to start on the left. Agreed. What do you guys think we should do first? Why not, right? If you're not sure what to do, that's usually not a bad idea. Notice that they're all to the first power. Nothing is squared or anything, so that's probably going to be a really good idea in this case. So if we're writing everything in terms of sines and cosines, I don't want to do anything with sine or cosine. What can I rewrite cosecant as? 1 over sine. What can I rewrite secant as? 1 over cosine. Okay? So just have 4 things multiplied together, right? So this is just like multiplying fractions, right? How do I multiply fractions? Do not need a common denominator to multiply fractions. Just straight across, tops to tops, bottoms to bottoms. So what would the numerator be? Good. And the denominator would be? Sine times cosine, right?
Oh, nice.
And that's all going to?
Oh, God. Wait, this is awesome.
So you got 1. And we're done.
I think I've been as happy as like, oh. Let's do 30.
30 to 35.
I'll do whatever you guys want me to do, man. You want to do 30? Sure. It's no big deal. That is the Greek letter alpha. It's just it's like a period. It's the end of the proof. No. It just tells the reader when you're reading that your proof is now finished. And now you might start like narration or whatever. Okay. They're basically the same, right? You can start on whichever side you want. Now I think to do this, starting on the left-hand side, I think is going to be a little bit trickier. But you can do that.
You say that because of the whole.
I say that because of the 1.
So, starting on the side.
I think you'll be happier starting on the right-hand side here. But we'll do the left-hand side also.
Why is that? I know that that's not
Right. And maybe you don't at first. Right?
Yeah.
And I don't know that from without a bunch of experience how you would know that. I mean, I know that because I've done like literally thousands of problems like this. So I have like lots of intuition. I can look at it and already see without actually writing anything down. I can see exactly how to do it. You're not at that place, and I don't know that it would be obvious to you which side to work on. I'm telling you right now that the right side is easier, and typically if you can avoid having like the -1s or +1s or whatever, that's probably to your advantage to do though, to pick the side without a bunch of those. But you could still get the right answer working from the left-hand side. We can do that. But let's do the right-hand side first. So to give us an idea of what we should do, look at the left-hand side. What trig functions do you see on the left-hand side? Only sines, right? Everybody agree with that? So let's try to rewrite the right-hand side with only sines. So sine squared I'm not going to do anything with. So we can rewrite cosine squared as 1 minus sine squared. Now notice that I put that in a parenthesis. Why did I do that? Because there's a negative sign in front of it. The cosine squared was negative. Because what am I going to have to do here? I'm going to have to make sure I distribute that negative. Just distributing the negative. So the sine squared isn't doing anything. That's staying where it is. But now that 1 becomes -1, and that negative sine squared becomes positive sine squared. Do you see it? What's sine squared alpha plus sine squared alpha? And what's left over there? And the -1, right? We didn't do anything to that.
Yes.
And we're done.
Wow.
Now, had we started on the right-hand side, or I'm sorry, the left-hand side, here's the trick. This is the one that I'm going to change. What am I going to turn 1 into?
Yeah, that's it. Wait, we're not done.
Well, people had asked about doing the left-hand side, so I'm just doing it as if we did left-hand side. So the trick here, if you had tried to use the left-hand side first, Matt, I'm doing this for you.
Oh, you are.
If I do the left-hand side first, here's the trick. Is I'm substituting 1. That's the one that I'm changing with an identity. I'm changing 1 into sine squared minus or plus cosine squared. And then I'll distribute my negative. And 2 sine squared alpha minus sine squared alpha is just sine squared alpha, which is what we're supposed to get. Now the holdup there was thinking to turn 1 into sine squared plus cosine squared, which is not an obvious thing to do, right? Typically, we wouldn't want to take something pretty simple like 1 and make it more complicated and rewrite it as sine squared plus cosine squared. But it's okay to do that. But that's why I said that I think you'd be happier starting on the right-hand side.
So let the other side of the cosine squared plus minus cosine squared, the 1 squared. How do you get sine squared plus cosine?
P1.
Oh.
Okay. Probably have time for 1 or 2 more.
33.
33. Okay.
Or 35.
Oh, okay.
Sorry.
Okay, which side did you want to work on?
So,
I think that's wise. What's the first thing that you want to do here? What do you want to do to the left-hand side?
turn them into this. Just kidding, no.
Everything's in terms of sines and cosines. Yep.
Multiply by the.
Well, there's not two fractions in the problem, so that probably doesn't make sense to do that. I'll give you a hint. It's not an identity. Look at the denominator.
Oh, combine line. Oh, you would cancel the.
You cannot cancel out the cosines because the denominator is part of an addition problem. There's not like terms to combine. Is there any factoring you can do?
I know. Oh, you can take out a. You can take out a sine squared.
Exactly right.
Yes.
That's exactly right. So notice in the denominator, we have 2 terms. Each of them has a sine squared in it. So when I take that out, I get that. Which at this point you should go cha-ching. What do you see here? Look for it.
Oh, sorry.
What is it, Kendall?
Can you cross out now? Because it's not going to.
Nope.
Never mind.
Look at your identity sheet.
Oh.
Hallie, what do you see?
Equals. Oh.
Sine squared plus cosine squared is 1. So
Sorry, actually, I was
so that turns just into that, right? Because 1 times sine squared is just sine squared. Okay?
That is an equal cotangent.
And that is exactly cotangent squared, right?
Yes.
If you look at your identity sheet, look at the Q2. Cotangent is cosine over sine. So cosine squared over sine squared is cotangent squared.
We have 20 days in the
I feel so much
20 days
better.
and 9 hours.